Okay, in this presentation we are going to look at a decision theory question. So a casino operator moving into a country for the first time must apply to the casino regulator for a license. Okay, there are 3 licenses to choose from: slots, dice and cards, each with different running costs. Okay, the casino operator has to pay a fixed amount annually of 1.3 million, okay, to the regulator, plus a variable annual license cost. And this license cost depends on the game, slots, dice or cards. So it's either 250,000 for slots, 550,000 for dice, or for cards it's 1.15 million. Okay. So just to be clear, if the casino operator, if they are going for slots, they must pay 1.3 million plus 250,000. So that would add up to 550,000. Apologies. Now, the expected revenue from each type of game is as follows. So the expected revenue is $60 for slots per customer for slots, 120 for dice, and 160 for cards. Now, the casino operator is uncertain about the number of customers and decides to prepare a profit forecast based on cautious, best estimate, and optimistic numbers. So there's 3 forecasts: cautious, best estimate, and optimistic. And the figures under each forecast are 14,000, 20,000, and 23,000. Okay. So determine the annual profits under each of the possible combinations of forecast and game type. Determine the minimax solution for optimizing the profits. Okay. And then determine the Bayes Criterion solution based on the annual profit. Given the probability distribution, we expect the cautious outlook to be realized. There's a probability of 0.2. The best estimate is 0.7, and the optimistic estimate we predict with an occurrence will happen with an occurrence of 0.1. Okay. Now, so essentially what we have to do here is calculate the profit. So there's 3 steps to this. First off, we calculate the expected revenue, projected revenue, the costs, which is straightforward enough. I discussed it already, and then the profits. Okay. Now it's sort of good to keep a sort of table format going. Okay. Now, 14,000, 20,000, and 23,000. Those are the 3 estimates for the 3 different forecasts of the number of attendees or number of patrons at the casino. And we expect to make 60 per customer from slots, 120 from dice, and 160. Okay, so essentially what we're doing here is the projected revenue is, in each case, it's 60 times 14,000. That gives us 840,000. Likewise over here, best estimate projection, if we're going with slots, is 1.2 million. And then at the other side here, cards, on optimistic forecasts, we project a revenue of 3.68 million. Okay. Now, I've discussed the costs already. They're consistent across all of the forecasts because we don't know what's going to happen. So it's 1.3 million plus the these costs here. Okay, so it's 1.3 million plus those, and they're the same for cautious, best estimate, and so on. Okay, now the profit is the difference between the two. For example, it's just in shot there. So for slots under the cautious forecast, we expect revenue of 840,000, but the revenue will be 840,000, but the cost will be 1.55 million. So we project a loss of 710,000. Okay, and in fact, we just continue through it like that. And so at the other end, we cards under an optimistic outlook, we expect revenues of 3.68 million. The costs will be 2.45 million. That means the profits will be 1.23 million. Okay. So that's what we have to do. Work through those. Now, let's just go through it here. So the slots is dominated by dice and cards. So it could be left out from here on in. So we only have to look at dice and cards. Essentially, just looking at that, going back up there, we never expect to make a profit off slots. So we can forget about that. I'll include it from now on, but it's not wrong to exclude it from now on. So the maximum loss in each case is, so essentially they were asked here for the mini-max solution, okay? And the mini-max solution is we're looking at the maximum losses and picking out the minimum of those, okay? So actually, sorry, let's just go back and read the question properly. I'll just go up here. Determine the minimax solution for optimizing the profits. Okay. So in the case of profits, the minimax solution is picking out the best of the worst case scenarios. Okay. So essentially, we're looking at the profits. Okay, and picking out the minimum of those profits. Okay. Sorry, the minimum profits are actually can be looked at in the terms of maximum losses. Okay, and so we're a loss of 710,000 is the worst case scenario for slots. The worst case scenario for dice is 170,000 as a loss, so minus 170,000. And then for cards, it is the worst case scenario is that we lose 210,000. Okay, so of these three worst case scenarios, what's the most favorable? That is the dice. So the minimax solution is the dice. Okay, so in the case of expected profits and so on, what is the minimax solution? It's the most favorable worst case scenario. Okay, that's the best way to interpret it, and then work from there rather than a very straightforward definition, very dogmatic definition of what a minimax is. It's the best of the worst case scenarios. Okay? For these type of questions, of course. Now, the base criterion solution is the largest expected profit. Okay, so we're given these probabilities, 20% cautious, 0.7 for best estimate, and 0.1 for optimistic. Now, essentially what I do here is calculate the expected profits as the expectation of a discrete random variable. So 0.2 times minus 710 plus 0.7 times minus 350,000 plus 0.1 times minus 170,000. So anyway, just work through it like that. Let's just go over here. I'm slightly out of shot. So the expected profits are, we expect to lose 404,000 in slots. That's our expected profit there, a big loss. We expect a profit of 442,000 under dice, with dice, picking dice. That's a sort of, and the expected profit is 606,000 from cards. So the highest expected profit comes from cards. So the Bayes criterion directs us towards picking cards as opposed to dice, which was the minimax solution. All right, that's grand. We'll leave that there.